If we want to extend our idea from that last video further, we get towards a thing called the fundamental counting principle, which basically says that if we have m options for one thing, n for the second, o for the third, p for the fourth, and so on down the line as far as it goes, it will be fixed, but for our purposes here, I'm just letting it go to say that it can be for any number. You want to get the total amount of options? You just multiply the number of options you have in each case. To be a little bit more exacting, we could say that the number of ways in which a series of successive things can occur, successive options can be chosen, successive outcomes can happen. This is found by multiplying the number of ways in which each part can occur separately. So if we want to think about the clothes that we talked about earlier, we want to take that a step further. If we had two pairs of shoes to add on top of everything else, or I guess more appropriately multiply on top of everything else, then we would have 2 options for the shoes, 3 options for the pants, and 2 options for the shirts, for a total of 2 times 3 times 2, or 12 options in total. Where, like I said, it's a very straightforward extension we have here. If you want to think about it in some ways, you could say, okay, give me these first 2, then that's some total number of options for the first 2, it's its own thing. Multiply that by the next one. Group these all together, multiply that by the next one. It's really just the 2 thing extended further and further out. It's sort of an idea that hints at a construction called induction, which we've seen a bit of before, we've talked about a little bit before, but don't worry too much about that. Here, this is giving a little bit more backing since we're getting towards the end. I want to make sure we're seeing all of the details we really can. But anyway, this is a pretty short section. It's pretty short sections for all of this week. Let's finish off with a couple more examples. For this, suppose you are planning your schedule for next semester and need to pick sections of Comp 2, Gen Chem 1, and Statistical Methods. Checking the course offerings, you see 9 sections of Comp 2, 3 of Gen Chem, and 7 of Stats that you can take. How many total options for your schedule can you make? So for this, we can understand here that we have 9 options for Comp classes. I'm just going to say Comp instead of Comp 2. We have, along with that, 3 options for chemistry, and we have 7 options given there for stats as your options in each case, where I picked these numbers to be a little bit more reasonable. There's sometimes more sections of chemistry than just 3. We'd be in real trouble if that was all we could offer in a semester for how many students take that class. And I don't know exactly how many you get for comp. And usually we have more than 7 stat sections, but it varies. Anyway, here, if you want to know how many total options we have, you just take these 3 numbers and multiply them together. So you have 9 times 3 times 7, which ends up being, depending on how you want to see that, either 21 times 9 or 27 times 7 or 63 times 3. However you want to think about that, you're going to end up with 189 total options for your schedule under this arrangement. So let's get one more example here to really make sure we're understanding the idea of how this works. Suppose you're taking a 12-question multiple choice exams. 2 of the questions are true/false, and the rest have 4 letter choices. How many ways can you answer all of the exam questions? So with something like this, we should understand that technically speaking, a lot of these options don't matter. Like if you're taking a test carefully, if you really understand what a question is asking you, you should be able to tell that at least one of the answers on many of them is worthless, and there's really only a couple that matter, but we're taking all of the possibilities here because we can get all of our options, because that's the way we have to think about things in terms of the probabilities that we'll get to later on in this chapter. So, because we're being as broad as possible, even though in reality you hopefully can recognize that some of these things wouldn't actually be good, what we can do here is think about our options, ignoring the potential for leaving a question blank as well, because we're going to assume you at least guessed, you at least give yourself a shot. For this, we have 2 options for each of the true/false questions, so 2 times 2 coming from there. Then we will have 4 for the 3rd, the 4th, the 5th, the 6th, oh boy, I have to count now, 7th, 8th, 9th, 10th, 11th, 12th, 13th, and I believe 14 was all we had there. Oh, I went too many. There's too many in here. There should only be 12. My mistake. Bad erasing with the thumb. Bad erasing. But I think you get the idea. Anyway, there we have all of these options, which if you wanted to, you could condense down with some exponential notation. That we have 2 squared 2's, because there's 2 of them. That's what square means, 2 to the second. We're taking 2 copies of it. Along with 4 raised to the 10th power for the 10 fours in there, which if you multiply that out is going to end up being a somewhat large number here that we would end up getting 4,194,304 arrangements, where again, a lot of those aren't going to be worth anything. And if you just guess C every single time, well, you won't have very many options at all. But this is the total amount we could possibly consider, which, as I said, is the sort of thing that's important to remember for when we get back to talk about probabilities later. Anyway, for now, we're going to keep developing these ideas of counting, moving into section 11.2 to look at a special kind of counting we have called permutations, for when we deal with cases where we have unique selections and we care about ordering. See you in there.